As we have seen in our previous module that while talking about the antifoams, we just try to understand that what are the factors in which and what are the pattern by which the foam can produce during the fermentation process. But in this module, we will talk about the different strategy to control the foam formation. So you can say that when there is the excessive foaming is encountered, there are the three different approaches to solve this problem. Number one, the first approach that we have to avoid the foam formation. We have to select and design the medium, and then we select different ingredient of the fermentation medium that not facilitate the foam formation, then inhibit foam formation, especially the nitrogen compounds. So try and avoid foam formation by using a defined medium and a modified of some physical parameters in which the pH, temperature, aeration and agitation. Just by the controlling of a media component and the physical conditions. This assumes that the foam is due to the component of the medium and not a metabolite. Sometimes it happens then when there is a foam due to the product formation that is due to the metabolism or the metabolites. So second case, when there is the foam is unavoidable, because when we know that foam has to produce and then that is unavoidable, then anti-foam should be used. And this is the most appropriate approach during fermentation process, because the use of the anti-foam is almost unavoidable. And third approach is use of mechanical foam cutters, just to avoid the addition of anti-foam, because we know that anti-foam addition effect on the dissolved oxygen into the fermentation media. So that's why the third approach is just to use the mechanical foam cutters. So antifoams are basically the surface active agent that reduce the surface tension in the foam and destabilizing the protein film formed around the air bubbles. So the hydrophobic bridges between two surfaces and the displacement of the absorbed protein and the rapid spreading on the surface of the film is the mechanism behind just to avoid the foam formation and to have less foam formation and their effect of the antifoams on the foam. As concerned that ideal antifoams have the following properties. You can see here are different properties. That first is the antifoam should disperse readily and have a fast action on the existing foam. Number one. And the second, the antifoam should be active at low concentration. Third, the antifoam should be long active in preventing the new foam formation. Not only that effect on just to kill the foam, but that also hinder the foam formation. As concerned the fourth, that the antifoam should be metabolized by the microorganism. If the antifoaming agent can be utilized by that organism, then that is most important. Should be non-toxic to the microorganism. If we say that can be metabolized by the organism, and then that should not be toxic to that particular organism. So as concerned, then that should be non-toxic to the humans and the animals, environmental friendly. And the seventh case, that the antifoam not cause any problem in the extraction and the purification of the product. So that is very critical. And then eighth is that antifoam should not cause any handling hazard. Handling hazard means when we have to use the antifoam that has the tendency to be prepare different solutions according to the fermentation process. And the ninth point is the antifoam should be cheaper As concerned the 10th and the 11th, that should have a minimum effect on dissolved oxygen, either having no effect, either having a very less effect. The last but not least, that antifoam should be heat sterilized, because during the fermentation we have to add directly the antifoam into the fermentation medium. So if that contains some microorganism and contamination, that can affect our fermentation process. So that's why that antifoam should be heat stable, so we can sterilize during the fermentation process. So these are the 11 different points by which we have to select a suitable antifoam for our industrial fermentations.